Okay, welcome to this afternoon session, the closing session of our two-day symposium. Can I just remind people to turn their phones off if they've had them on at lunchtime? And I'll try and keep you to time so we can all leave on time. So our first paper is by Daniel Meekin on investigation into the closing force of passenger/goods lift automatic power operated doors and recommendations to reduce the risk of injury to lift users. Daniel. Thank you.
Hello, everybody. Good to see you all. I'm from Zurich Engineering, which, as you'll probably recognise by the logo, is part of the Zurich Insurance Company. This presentation is a very brief summary of a dissertation that was completed towards the end of last year. So why was the project chosen and an investigation carried out? So within the UK, between 2002 and 2010, 266 people had been injured in lift-related accidents. And the most common injury is entrapment between the doors as they are closing. Admittedly, it's not recent data, that the data is quite difficult to obtain, or impossible, as I found out. But it's still reasonable to conclude that the main interface that passengers deal with is the moving lift doors, which would expectedly increase the risk of injury, and it does happen. It's also becoming increasingly common to witness lift passengers stalling the closing lift door, whether it be by the hand or by the foot, with the expectation there that all lifts are fitted with a full height light curtain. The passengers seem to be becoming increasingly oblivious to the risks associated with this practice. There's also a general feeling within the lift industry that more could be done to improve the safety of lift automatic power operated doors, especially where doors exceed the closing force limits. And this is evident by the test 4.17 within SAFED LG1 in June 2020. So EN 8120 states that the effort needed to prevent a door closing should not exceed 150 newtons, but this excludes the first third of travel. The protective device shall automatically initiate door reopening if a person crosses the entrance. And that final point is quite important, hence why it's underlined on the slide. It's only there to detect a person crossing the entrance. The device may also be deactivated during the final 20 millimeters of door closing, and it also doesn't have to detect obstacles smaller than 50 millimeters in size. The Lift Regulations 2016 states that a device must be fitted to prevent the risk of crushing when the doors are moving. So it's reasonable to state that the closing force is a final measure of safety to reduce the risk of injury to lift passengers. And although there's little evidence to suggest why, the 150 Newton figure is a widely accepted figure now in standards and guidance worldwide. For example, the figure is also used for powered retail doors manufactured to EN 16005. On the slide, on the left-hand side, you'll be familiar with the single photoelectric sensor, the Magic Eye. In the UK, there's no mandatory requirement for upgrading lifts. So there's many of these type of devices still out there and in use, which obviously present greater risks when a passenger is expecting a full height light curtain to be fitted when they stall the lift door. But even with lifts fitted with a full height light curtain, as in the right-hand side of the slide, due to the narrow beam of the sensor, because again, it's there just to detect a person crossing an entrance, there's still potential entrapment areas for fingers which are identified in yellow. So during field research that was conducted, 384 closing force measurements were recorded from in-service lifts using a simple but calibrated door pressure gauge as seen in the left image. Measurements were taken from the top of the car door, top of the landing door, and then the bottom of the car door, bottom of the landing door. But the measurements, these measurements were also taken at the ground floor and one other floor. 50% of the lifts that were tested applied over 100 newtons, but concerningly and perhaps surprisingly, 25% of the lifts that were tested applied a force of over 150 newtons. Analysis of the data has allowed comparisons and conclusions to be made, which I'll run through now. So when comparing forces between the bottom and the top of the door, 60% of the lifts had forces that differed between the top and bottom. And where there was this difference, the force was greater at the top of the door in 91% of the cases. Also, as can be seen in the table, the average closing forces are higher at the top of the door in every comparison. So it's reasonable to state that the door closing forces are generally greater at the top of the door, and that's expected to be due to mechanical losses when the measurement is made further away from the door operator and door hangers. The second trend, measurements were recorded at the ground floor and one other floor, and 60% of the lifts that were tested had closing forces that differed between different landings. And the forces were greater at the upper landing where any of these discrepancies were identified. And the vast majority of lifts that we tested featured sprung landing door self-closing devices. So the reason for the lower figure at the ground floor is likely due to increased wear, stress and strain on what's commonly the most utilised landing, which would in turn provide less of a self-closing force on that landing door. Trend 3, measurements were taken from both the car door and landing door, obviously when the doors were coupled at a landing. And when comparing the forces, they are very, very evenly matched, which suggests efficient coupling between the doors. A comparison was made between harmonic door operators and linear door operators. Half of the door systems fitted with harmonic operators applied a closing force over 150 newtons. Interestingly, 88% of the harmonic systems applied over 100 newtons, which compared to only 48% of the linear counterparts. Harmonic operators are clearly more mechanically complex, and the advantages of a linear operator are clear. It's reasonable to state, therefore, that harmonic door operators generally apply a greater closing force than linear operators. And that said, I'm not saying that the harmonic operators are inherently unsafe, because clearly they can be adjusted to operate safely. But maybe as they become less and less popular, the fine adjustment of them is becoming a lost skill. In comparing side opening doors and center opening doors, the average closing forces for side opening doors is greater. And this is likely due to the greater force that's possibly required to overcome the inertia of often larger single panel doors, certainly the areas where lifts are tested, local authorities, for example. I did expect to be able to make some trends that would paint a picture of closing forces depending on the setting of the lift. So I'd expected lower closing forces in care homes or hospitals, for example, but surprisingly, there were no trends evident with this. I compared lift automatic power operated doors with other powered door systems to see if there's any improvements to safety that can be made. And the first comparison was with train body side doors. So they're closely relatable to lift automatic power operated doors. For example, traction power to a train is inhibited until every body side door is closed and locked. The train body side door standard EN 14752 is an 88-page document that details just the safety of train body side doors. This compares to just 15 pages in EN 8120. Revisions to the train body side door standard were published in 2005, 2015, 2019, and already amendments to the latest edition are available for public review. And the most basic safety measure, which is quite obvious, is that train body side doors have to be applied with a simple entrapment warning sign to highlight the clear danger to passengers. The sign highlights the danger, and some lift duty holders and those that are responsible for the operation of lifts have started applying similar signage to lift doors, but it's quite rare, and the problem with that is that the signs will differ between lift operators. Additional safety measures with trains are that automatic door closing is only enabled when there's nobody in a door portal for a specified time period. And I noticed in one of the presentations yesterday, McCullough, I think it was, that in America, the latest code stipulates this door portal area. Detection of obstructions have to occur within 1 second, and there has to be a standardized audible signal when the doors are closing. Second comparison that was made was with powered retail door systems, and perhaps the most utilized powered door system, certainly within the UK. And the risks presented due to the high foot flow through power operated doors is recognized within BS 7036-1. And it stipulates that operational safety checks should be conducted periodically by the property occupiers. Also, in accordance with BS 7036-0, the signs on the slide, so keep clear and automatic door signs, must be fitted to give users advanced warning of the door operation. And it states that in certain settings, these operational safety checks have to be carried out weekly. So in hospitals, for example, these have to be carried out weekly, and the check must include the operational check of the non-contact device. In addition, EN 16005 states that the door closing forces have to be measured in the worst possible configuration and details exact locations of where to measure the closing force from. So to conclude the summary of the work that's been carried out, recommendations have been made in three areas of responsibility, let's say, with respect to the operation of lifts. So for the inspection bodies and maintenance providers, that the field data has clearly shown that more needs to be done to control excessive door closing forces and reduce them where necessary. By using the field data, a measurement point can be recommended where the force is likely to be highest, which is at the top of the door at one of the less utilized landings. We should be ensuring that supplementary test 4.17 is routinely carried out where door closing forces are not actively monitored. And the recommended intervals in accordance with SAPED LG1 is every 5 years. For lift owners and duty holders, there should be a check in the condition of lift doors periodically and include an operational check of the non-contact device. To deter passengers from interfering with lift doors, it's also recommended that they apply warning signs to the lift, as we've seen. Closing forces should also be set as low as possible, depending on the lift location. So care homes, as I've said, and hospitals, it's reasonable to have the closing force set as low as possible due to the expected passenger use. It's also noted that there's no mention of door closing forces within EN 8170. Studies do show, in fact, that hands and fingers can withstand far less force than 100 newtons, and there's much evidence out there that suggests that closing forces should be reduced to below 100 newtons, which would obviously limit the risk of cushioning injuries directly. The recommendation for the lift standard, well, it's clear that the presentation shows that there are opportunities for safety improvements that can be made, especially when we compare lift automatic power operated doors to other door systems. Therefore, it's recommended that a review is carried out with the hope that safety can be improved, and it's improved continuously and consistently across the board.